Welcome back for part 2 of Module 6, Lesson 2, Solve two-step equations in the form of px plus q equals r, because that makes perfect sense to y'all. Here we have a problem that's a good example of px plus q, because right here you have px, all your x is your y, minus q, instead of plus q, equals r, which is going to be your 3. These are the things we're talking about. Now this one involves some subtraction and some negative numbers, but we're going to work it the same exact way we worked the last one we did in part 1, where we're going to start off by undoing addition and subtraction, and you see that right here. They said plus 7, actually minus 7, so they added 7 to both sides. I really wish they'd slowed down how they showed the work here so it didn't overwhelm you. These 7's zeroed out, leaving negative 2y that they brought down. And on the right hand side, signs were the same. They found the sum with a sign from the larger number going in front of the answer, giving them a positive 10. Then they took this negative 2y equals 10, they brought it down, and they undid multiplication and division by dividing by the negative 2 on both sides. Put a line through these negative 2's right here, and when you do that, 10 minus 2, well, that's just going to equal to 5, and a positive divided by a negative, that's going to end up being a negative for negative 5 to be your final answer. That is a great example, though, showing your work. That's the kind of stuff I must see, and you're going to get an opportunity now to show me that you understand it on extra example 2. As you're working this problem, make sure that you're showing all your steps on paper with a pencil before you submit your answer. You have to have the work on paper first. Go ahead and solve it. Alright, undo addition and subtraction first. The number that's being subtracted is 5. It's minus 5, so we're going to take and add 5 to both sides. When I do that, negative 5 plus 5 zeros each other out. Going to put a line through it, and that's going to leave me with a negative 3y on the left equals 10 plus 5. That's going to become 15. Now I'm going to take these two parts, bring them down. Negative 3y is equal to 15, and we're going to undo multiplication and division. Negative 3 is multiplying itself times y, so we're going to take and divide by negative 3 on both sides. The negatives divide each other out, becoming positive. 3 divided by 3 is 1, and 1 times y is y. 15 divided by 3 is 5, and a positive divided by a negative is a negative, which means that y is equal to negative 5. Plug in our negative 5, check it, and the answer checks. Keep in mind, this is showing your work. This is what I must see, and if I don't see supporting work like this on each and every problem of this type in your homework, you would have done it just for fun. And now we're going to dive into example 3, which is the same basic thing, only now they're throwing some decimals at us because they know how much you all love decimals and they don't want you to feel left out. So the original problem was 5x minus 3 8/10 was equal to a negative 6 4/10. Undoing addition and subtraction first, 3 8/10 was being subtracted from x, so we're going to undo that by adding 3 8/10 to both sides. These 3 8/10 will zero each other out. Put a line through that, and what are you going to be left with over there? Be left with 5x. On this side, we have signs are different. Find the difference. So let me come over, and we're going to do some work on that. We had, let's see if I can get it to move here. Negative 6.4 plus 3.8, signs are different, so this is a subtraction problem. You can do some borrowing, make that a 5 and a 14. 14 minus 8 is 6. 5 minus 3 is 2. Decimal goes there, and the sign in front of your larger number goes in front of your answer. So, jumping back over here, we're going to put a negative 2.6 in. Now they've set those two equal at 5x is equal to the negative 2.6, and they undid multiplication and division by dividing 5 on both sides right here. 5 divided by 5 is 1. 1 times x, that's going to equal to x. And then on this side, 2.6 divided by 5, well, let's jump back over here again. 2.6 divided by 5, 5 goes into 2 0 times, annex into decimal. 5 goes into 26 5 times, which 5 times 5 is going to be 25 with 1 left over. Now you may be tempted to turn this one into a mixed number, but they work the problem as a fraction or as a decimal, so we need to give them an answer as a decimal. That means we're going to annex in a 0, bring it down. 5 goes into 10 2 times. 2 times 5 is 10, and that gives nothing left over. So I get 0 and 52 hundredths, but I also have a negative divided by a positive, which means my answer is going to be a negative 0 and 52 hundredths. Hit to check, and everything checks perfectly. This is showing your work, folks. This is what we must see. And now it's going to be your turn to pause the video and solve this problem on your own. Make sure you're working it out on paper with good quality supporting work and submit your answer to see if you're correct. Now hopefully you took the time to do that. For this one, we're going to start off undoing addition and subtraction first. And what I'm seeing that's being added or subtracted, if I can get my pen to start working here, is, there we go, the 5. 5 is being subtracted from our variable, so we're going to take and add 5 to both sides. When I do that, these 5s are going to be zeroed out, and I should emphasize the fact that it's being subtracted because it's a negative 5. This plus sign right here, it belongs to that number right there, okay guys? So with that said, the 5 zeroed out, leaving us 0 and 3/10 x is equal to, and then I have 7.09 plus 5.0. That is going to leave me a 9 and a 12 for a 12.9. From here, we're going to take and make a new row. 0.3x is equal to our 12.9. We're going to isolate our variable by dividing our 0 and 3/10 on both sides. These, of course, divide out becoming 1, and 1 times x is x. We also need to do some grunt work, so 12.9 divided by a 0.3. Bounce a decimal till you hit the wall. Bounce a decimal inside the house the same number of places to the right, and move straight up. 3 goes into 12 4 times. 4 times 3 is 12 with nothing left over. Bring down your 9. 3 goes into 9 3 times, and 3 times 3 is 9. Once again with nothing left over, so our final answer, x is equal to a positive, is it positive? Yep, it is indeed a positive 43. Jump back over here, type in our 43, and hit check, and the answer checks. Easy math. Now we would indeed be remiss if we did not also go over some problems involving fractions like this one right here. And while some of y'all don't care much for fractions, you should be used to them by now, it's going to work the same exact way. You can see here they undid addition and subtraction. You had a positive 4, a plus 4 right here that they subtracted on both sides here and here. That zeroed out on the left, leaving 1/5 r right there, and on the right, signs are the same. Find the sum, which gave them a negative 5. Sign from the larger number went in front of the answer. Next, they undid multiplication and division by multiplying both sides by the reciprocal of 1 over 5. That was 5 over 1, or just 5. Now, if you recall, I've encouraged you to always do this after the number you're doing it to, but either way, 5 over 1 times 1 over 5 equals 1. 1 times r is r. And on the left-hand side, 5 times 5 is 25. Positive times a negative is going to give me a negative 25 for our final answer, and everything checks. Same exact process you've used on the other problems, only now we're involving some fractions in it. Now it's going to be your turn to work extra example 2. I want you to take and pause the video and work this problem on your own, and there it is. Do it. Alright, hopefully you got it right. We're going to start off by undoing addition and subtraction. 3 is being subtracted from x, so I'm going to start off by adding 3 to both sides. When I do that, these 3 zero each other out, leaving a negative 1/6 times x is equal to 2 plus 3. Well, that's going to end up being 5. Next, we're going to keep change flip as we undo our multiplication. We have negative 1/6 times x. So to make that go away, I'm going to multiply both sides by the reciprocal. also known as dividing both sides by 1 over 6. So on the right hand side, I'm going to have 5 times, and this 1 over here, I'm just going to put it as a negative 6, because negative 6 over 1 and negative 6, it's the same thing. I'm multiplying it by a whole number, no reason for it to be a fraction. These just zeroed each other out, leaving, or can be divided each other out, becoming 1. 1 times x is x. On this side, 5 times 6 is 30. Positive times a negative is a negative for a negative 30. Jump back over to our problem, type in our negative 30, hit check, and the answer checks that simply. This, once again, is showing your work. This is what I must see. If I don't see that on each and every problem of your homework, you will have done it just for fun. Now the last thing we're going to do is compare doing two-step equations using the arithmetic method versus the algebraic method. Using only numbers and operations to solve a problem is going to be your arithmetic method. However, if you use variables to solve it, then you're going to have the algebraic method. Consider the following. Natalie is participating in a jogathon. Her goal is to raise $125. She has collected 80 and will receive $3 for each lap around the track she jogs. How many laps does she need to jog to reach her goal? Well, if you were to use the arithmetic method, it would end up looking something like this. They took the $125 goal minus the 80, and that gave them $45. And then from there, they acknowledge that, for every lap she does, she gets $3. So they divided the $45 by 3, and that gave them 15 laps, which was her goal. To do the algebraic method, they set it up as an equation. The $125 was equal to the $80 she already has, plus 3 times some number of laps. They subtracted 80 on both sides, giving them 45 is equal to 3x. Then they divided 3 on both sides to find out that the x was equal to 15. Now, this arithmetic method, y'all use that a lot in elementary school, where you just kind of plug through it. You can't do that anymore, folks. We're big kids now. We're doing big kid math. That means the algebraic method is the only thing I'm going to give you credit for on tonight's homework. With that said, y'all go ahead and stop the video. Start working on your homework. Make sure you're giving me good algebraic supporting work so I can give you good credit for it.